Hello guys, it's a video on tautomers. As you can see the topic in the comment section. I was seeing that many of the comments were there that students are asking to make a video on tautomer because they were facing a lot of problems or circumstances in solving the book of M.S. Johan. So here it is. Now tautomers. Tautomer, it is a special type of functional isomer. It is functional isomer in which two structures distinct from each other are in dynamic equilibrium with each other. Forms are known as tautomer. You must be knowing about tautomer. That I'm just going to be giving you an example. You are aware of this CH3, CH2, CH2, COOH, and CH3, CH3, CH double bond CHOH. What do you think? What are these? These are functional isomers. But as they are tautomers also. Now, students, I am going to be giving you some of the examples how tautomers are defined. There are two types of tautomers. There are two types of tautomers. Dyad system and there is triad system. In dyad system, suppose there is a bond AB and this is selected with H. Now, as in the definition, it is in dynamic equilibrium. So I have make up the reaction sign like this. It is in equilibrium, dynamic equilibrium. Okay. Now, if it is tautomer, then it is going to be like the tautomerization of it. At position 1, and this is position 1, and this is position 2. So this is going to be changing from 1 to 2. Now, another example. Example says H, C triple bond like this, and triple bond N, H. So HCN and HNC. This is HCN, and this is what? HNC. This is HCN, this is HNC. So over here it is called what? It is called cyanide, and this is called isocyanide. This is tautomer. Now coming another examples, I'm going to be taking you CH3 C triple bond N, CH3 C N triple bond like this. This is functional as well as tautomer too. Now it is coming. Now triad system. Now, triad system. In this system, hydrogen migrate from atom 1 to atom 3. There are triad. Suppose this is C, C, O, and this is H, like this. Okay. Now, 1, 2, 3. You've got 1, 2, 3 over here. This is H, this is CC. Now what is going to be happening, that it is in dynamic equilibrium too. Now what is going to be happening, this particular hydrogen is going to be just coming over here, and this double bond is going to be broken and going to be coming over here, like CHC double bond COH. This is the tautomer. So what are the conditions? So there are many conditions for tautomers, which is in triad system. Tumors, sorry. tautomers. Now, as we know, as we know, suppose x, y, and this particular over here is selected with h, and this is z. Okay. Now it would go in the dynamic equilibrium to be like y, z, and h. Now, condition number one. What should be the condition number one? That electronegativity of x should be greater than electronegativity of H. Over here it should be carbon. Carbon, or that particular atom whose electronegativity is actually greater than that of hydrogen. So over here, this over at the position of X, that atom is going to be attached which has more electronegativity as compared to that of hydrogen. Now, condition number two, it is electronegativity of Z should be more than electronegativity of Y. These two conditions are there for triad system of the tautomers. Now I'm going to be giving you some of the examples how tautomers are actually solved. Now I've given you so example number one. Now what is going to be the tautomer of this? Sorry, H. What is going to be this? It is actually going to be this. Example number one. Now second I would like to give you and this is hydrogen. Now as I have told you, this hydrogen is going to be attaching with this particular atom and this double bond is going to be coming over here. It is in the dynamic equilibrium, so this. So what is it? It is enamine. This is I. Now I'm going to be giving you some of the examples of what? Of real one more example. What is going to be here? There are going to be two. Number one, it is going to be C, C, C. OH, this side, C, C, C. And it's going to, or it could be like C, 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 and over here it is going to be. So there are two possibilities of this. Now a topic called, it is a very important topic for the IIT Advanced, keto enol tautomerism. Keto-enol tautomerism. So keto-enol tautomerism, in this, the definition of this is carbonyl compounds, which is aldehyde and ketones, having at least one alpha hydrogen, then it exhibit keto enol tautomerism. Now as an example I'm going to be giving you, I'm going to be making a compound OH. Is it a keto-enol tautomer? See, the carbonyl compounds like aldehyde and ketones having at least one alpha hydrogen attached, then it will exhibit keto enol tautomer. Now I'm going to be showing you there are alpha hydrogens. Now over here there are two, this is the double bond. Now over here and here I'm going to be showing you that again make the compound. This compound is like this, hydrogen 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 and hydrogen, and like this, isn't it, this compound? Now can't it be like this, or OH like this? So there are two possibilities of it, and over here there are 4 alpha hydrogens. 4 alpha hydrogens. Okay, many of you would not be knowing about alpha hydrogen, so I'm going to be clearing the doubts of alpha hydrogen. What are alpha carbon and alpha hydrogens? See, what are alpha carbons and alpha hydrogens? Alpha carbon, suppose you have a compound. Yes, you have this compound. So you have this compound. Now, if I ask you how many alpha hydrogens, or sorry, not alpha hydrogens, but how many alpha carbons are there of point X? So you're going to be saying that this is CH3, this is CH3, and this is CH3. So for alpha carbon, they're going to be 1, 2, 3, and over here is also carbon, so 4 carbons for this. So X has 4 alpha carbons. Now I'm saying about alpha hydrogens. So at this point, like this is the structure, or the structure could be like this. Okay, so alpha carbon of over here, alpha carbon is going to be there, but if in case of alpha hydrogen, in this particular, what are you going to be finding? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 alpha hydrogens. This, at with respect to point X. Over here CH3, CH3, and CH3. So there are 9 alpha hydrogens. So you must have gotten the concept of alpha hydrogens, that and there are also many of the top. See, this is actually used in decarboxylation of the carboxylic acids. So it is equally important in that case. Now I'm going to be making some more examples. Like this is the compound. Does it show? Yes, of course it shows. Does it really? No, it does not. This is not HH. Over here in this case, I have shown that this is SH, but this in this case this is not HH. Over here actually it is CH3, 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 and double. This was it. This was not. Over here it is attached. So this is CH3. Over here, with respect to this bond, with respect to here, it has no alpha hydrogens, as 1, 2, 3, 4. 4 bonds are already formed. Same in this situation, so it is going to be no keto enol tautomer. So some of the examples I'm going to be showing now. Question or write tautomeric form. Question number second. You also have to say whether it is a tautomer or not. Now, in this case, okay, let me shift the copy over here. Now, in this case, is it a tautomer or not? Yes, it's a tautomer. Before only I'd shown. So this is OH. It could be here only, here also, or it could be here also. Now, this is what? Now, OH, OH, this or this, or OH, this or this. So, two forms are here. Now it is it going to be? Yes, there is. So the tautomeric form of is going to be double bond C OH and phenyl. This is the reaction. Now in this question, is it over here it is H, over it is CH3. Is it? No. Tautomer. In this case, is it? Yes. Or these two. Now in this case, is it going to be happening? Of course. This is the same question I here. Now this was all about tautomer and tautomerism.